Right. I've got about 6 copies of these, so I assume that we can all share them. All right. And what's on here is you've got this site, so I've scaled it up, right, just with the line work. Then I took some measurements off AutoCAD to try and determine whether these were correct, and that's what's saying. I had 15.36 along here, and I measured at 10.6, but I measured across here and it was right. So what we're going to do is check these dimensions. This is the digital aerial data with the Ordnance Survey mapping put on top of it, and you can see the line work's not too far away, and then you've got the overall map with the whole lot, right? So spread these out. As I said, I assumed that you could have 3 or 4 or 5 people using them, so just to get an idea what's going on. All right, somebody take one. I mean, I could have printed off hundreds, but it's pointless if everybody's going to so as I said, if you've got a site that you've been asked to do and you've got no information, you've been on the title deeds, the title deeds just give you a paper copy at 1250 scale usual. It's not ideal for you to do a preliminary design without a bit of effort. So the easiest way you can do it, a bit of effort, is to, as I say, get the digital data off the Pro map, get it into your CAD system, scale it up so that the grid lines equal 10 meters. Then you can verify and you can adjust it and end up with fairly easily a drawing. So if you like to hold that, so these are the types that you would get, and you can buy one of these for, this is a 60 meter for 30-40 quid. But as I say, so I've got a measurement across the wall from the building, main building, to the wall of 2.721, right? So if I go down here, I've got 2.65, all right? So 2.65 away from that is 7 centimeters, thereabouts, right? So that wall relative to the building is not bad, and I could adjust that. So if I'm going to use the building face as my control, I've done one measurement and I know that that's within 70 mil, 60, 70 mil, all right? So I can adjust that, so I can put another coloured line over there, correct it, and I can go around here and measure bits and correct it. And then I've got that line that I've measured from there to there, which I was talking inside, saying the Ordnance Survey will position the rectangle correctly, but what they won't do is they won't get all the other line work fine. But we could arrive at that, then we can use trilateration, other bits to fix the trees, to fix the end of the wall and whatever, and you start to build up a plan for your design. All right, that makes sense, yeah? So with a little bit of effort, a little bit of money spent on ProMap to get the digital data, you can start drawing up stuff as opposed to guessing a little bit. All right,
so
yeah?
Is that the ProMap there?
That's the ProMap, that stuff.
All right. Datum for this though?
Sorry?
You don't have a datum for this though, do you?
It's got 6.1 there, height above sea level. Is that what you're asking?
Starting point, or you know, the point that you're measuring everything off.
Well, if I'm going to highlight this area, which is the area that I've done my measurements from, I can take a measurement from there to there.
So this is your baseline,
yeah,
it?
Yeah, baseline, step in, measure that. And hopefully the overall, we can do that now and see what that's like, yeah? And then we can scale it with a scale rule and see how close it is. So if you use one of them types, and if we lay it out the front of there, and we'll go right up to the end of the building, and we use the scale rule to see how close it is, yeah? All right? Don't like scale rules? Don't like tapes? Oh, we're going to way up there now. Right, will it fit? Six. Right. So I measured 25.66. 25.66.
26.
25.66 from there to there. It's 1, 2. No, where's that? That's the wrong one.
No, is it 50?
It's with the 100. 100 one. So the first one, yeah. 25.66. So with 25. So they've got 26.05, right? And I measure 25.66. So it's 400 mil out, right? But it's not, as I say to you, they don't update this stuff very much because there's no development, right? So I can either change that line by 40 centimetres or change this back line, right? I know the distance over there needs to be altered by 50, 60 mil.
But you need to know whether it's this line or that line, don't you?
Yeah, but I can measure that bit in there.
Yeah.
So I can establish that as a baseline, and then I use that to measure everything else from.
Yeah.
All right.
Triangulate from that line.
Yeah, so I can go to that corner, I can triangulate from there to there. That one I can measure down there, like that one, I think on, what's your plan say, 6.6, right? So I've got 6.6 on there. So if I now physically measure that with me tape, yeah. I've got another little tape in there. Oh, where's he gone? That line there, that's the one, good man. Is that going to be big enough? 8 metres, yeah. So, could you hold it on that, just change the direction up there, please? Where it changes direction. And that's, that's 8.8. So that's wrong, right? But again, we can correct it. Yeah.
6.6.
Yes, it should have been 6.6, cheers. But again, that's not an issue, because what we're saying is that the Ordnance Survey is wrong, and that's fine being wrong, yeah? What we're doing is surveying it properly. So if we've got that, which we said was within 400 mils, so we either move that line or move that line, so we've got that as a baseline. We've measured that, and that's wrong by probably a couple of metres. It could have been under the vegetation when they drew it, and the guy on the big machine just says, oh, put it's only a wall, it's not bothered. But we can now correct it that way, and we can fix that point by taking a measurement from there, a measurement from there by trilateration. We've got 3 dimensions, we know that point's fixed, we know that point's fixed, we can do the same to the end of the wall. So you've got that baseline, and then you've got this line round here is now fixed relative to that. And that's how you build it all up, all right? And then you can add your trees, you can add the gully in the middle, and you can get up with a scheme that then you can start putting your changes to it. And you've got something that's not far away from being that far off because you physically measured it. And then if you continue it yourself, if you want to do it, you just build up from that. And as long as you keep checking yourself and checking it, then once in the new year, in January, we can take out the level, put levels all on it so we know the difference in heights. And before you know it, you've got quite an accurate survey. And if you want to bring in a professional survey company to do it, you've done a lot of stuff that you can easily verify how good the survey is. And if that area survey is all right, it means the rest of it's probably going to be the same bit. So you're getting confidence built into what you're doing. All right?
Yeah.
That makes sense?
Yes. Thank you.
Yeah.
That was 1 to 100.
What?
Scale of that.
The scale of that is 100 because this grid line, which I got off the OS, that should be 10 metres. Yeah? and then 10 metres that way. So all I've done is I've pulled this into AutoCAD and checked that I got 10 metres across the grid. And once I've got 10 metres across the grid, then I know everything relative to that grid is correct. But because we've now highlighted the errors in the Ordnance Survey data, which again, given the due that there's no major roads or buildings around here, it's all right. But we can correct that, we can correct that, we can correct that, we can correct the thing, so that we throw away their lines and we've got our lines that we know that are good. But the grid's still the same. And again, you can then measure from there to somewhere and put a point in, somewhere else put a point in, as I said. You can end up working your way and fill in the whole lot of it.
So if we need to adjust most of the distances anyway, why not just
start from scratch?
Yeah.
Well, you can. That's what I was going to do. I was going to just draw a few lines and measure all up.
Yeah.
Which is all right. But if you've got quite a site with quite a lot of detail and you start doing that, you've got to establish control, as in a baseline or something. Then you got to build it. And if you've got the capabilities of doing it and the time to do it, that's fine. But if you haven't, you've got to come up with the end of next week with a feasibility scheme for this. You won't have the time to try it. So you go and draw a few lines, put a few measurements, get in a bit of paper, draw it all up at the scale, and then make sure that's good. That could take you a couple of 3 days. Whereas this way, it'll take you an hour or two out in sight, but you've bought the information, and all you're doing is verifying that information. So you can get there quicker. Okay. All right. So yeah, you can draw a few lines if you're confident in doing it, and you can check yourself, and you use a baseline, do trilateration to convince what you're doing, and that's fine.
Is the grid always 10 metres?
No, they asked me a choice to do one. No grid, 10 metres, 20 metres, 25, 100, and I think 100 is the biggest one you could have.
And then you scaled it.
Well, is the minimum. Yes, I don't think you can go down to 5.
This is ProMap, sorry, isn't it?
That's ProMap,
They're
yeah.
both ProMap for some.
Yes,
Okay,
yeah.
okay.
Yeah, that's just the overall site. So I just put a square round the map of area of interest,
Okay.
and I think that was 20 quid or 24
So
pound.
that's
Okay.
10 metres.
That's the 10 metre, but that's not to scale. I
Okay.
can't, that's no scale. That's me just plotting it on an A4 sheet.
Okay.
So then I said, right, what bit am I going to do? We could have done the front of the cafe, and I thought, no, let's do this bit. It's just outside the door. And then I scaled it up, took a load of dimensions off it, and thought we'll verify them. And as I said, one is quite close. The overalls, you know, in proportion, percentage-wise, it's probably not too bad. This one was rubbish, and that's expected. As I say, you can get some sites that the whole the roadways, the buildings, and the boundaries are probably within 100, 200 mil, but you need to prove it, because you don't want to accept it all, because when you're doing your design for your client, and they'll say, right, go ahead with it, how much is that going to take? 65 grand is what I estimated. Then you find out that the site is 10% or 20% bigger. Once you start measuring it all, well, then your budget's going to increase by that. So you need to get down with a decent survey so you can base it all on that.
When you scaled that up, did you take points to scale it?
No, what I did was, in AutoCAD you can use that, so you can select the whole lot, use that as my origin, and say to it, this point here is the next point, I want it 10 metres away, and it'll just move the whole lot. And then you obviously want to take out a few dimensions to check it. So it's quite easy. Once you've done it once or twice, it's quite easy. All right. Any other questions on anything? I mean, ideally when we went down to Cambridge Cottage, because I had surveyed it all, I wanted the students to interrogate it. So I've surveyed it all. Now hopefully I wouldn't get an error like that, 6 metres as opposed to 8 metres. But we were doing trilateration and everything off around the face of the building in 2 points. So I had taken a whole bunch of dimensions off my CAD drawing and then said to the students, now check these dimensions, and they were all within 5-10 mils, which gave me confidence. It could have given me a red face, but it gave me confidence that what I'd done is correct. And that's what you want to do. So when you're verifying a survey, you don't want to check everything, but you want to check overall so it all fits together. All right? He's got his umbrella now, he's all right. I mean, basically that's the nuts and the bolts of it. I mean, we could come round and we could measure the other dimensions that's on there and actually measure up this and correct it all and do a drawing off it. And then you could do a preliminary design off it. But as this was just a site that I chose on Friday night they said you can't use Cambridge Cottage, can you use somewhere else? I said yeah, we'll do this. So we could spend time measuring it, but measuring is just holding it on the end of the type and pulling it out and watching the end of the type, because sometimes it's not zero, making sure your tape's a reasonable quality, and these ones are Stanley ones, I think. It's over there. So Stanley are a fairly good make. And if, like, you're measuring across from there to here, you don't want to pull it over the end of the wall and then down, because you're going to get that slope error problem. So you want to find a stick or something to do it. And Stanley do a right angle square. It's a folding right angle square, 1.2 high. And you could sit that on, as that's level, the square will come up here. And if you, it won't never go back forward that way, because it's lying, the base is lying on there, but it will go back and forward that way. So if I'm measuring from a point over here to here, that distance change, even though it might not be a right angle, it doesn't matter to this. If I put a pin and a nail in there and I want to measure to it, because that's accurate. But if I had the straight edge or the right angle triangle that way, it can go that way, and therefore my measurement will change. All right, so you need to use something that you can keep it vertical, so when you measure your tape to it, that you're compensate, because it's flat over there, flat to the top of the wall and flat to here. All right, and then you can relate that point accurately on a 2D drawing to that point over there. And surveyors will have little nails. I've punched in 2 nails when I came here today. There's one over there called a Hilti nail, right? That's a Hilti nail, right? So if you see them about, that'll be a survey station. And that's what a surveyor would use to set his instrument over and then survey it all by angles and distances. And there's another one down there, which is a slightly different type of nail, PK nail, and it's the same idea. And what I would do is I would accurately measure to a millimetre the distance between there, and the heights and its position relative to this building. And then I can put hand on heart, and anything that I measure from these points will be good. And there's never an issue on it.
So that's the baseline then? They've used the nails as the baseline?
Well, we were just discussing the baseline. Personally, if I had surveyed them in an instrument, I would use the nails as a baseline and measure from that.
Yeah.
And because this corner is past this, I would just hook the tape on there, pull it through that to here, and then offset that at right angle to there. Yeah. Yeah? And the idea is making sure you get 90 degrees. So when you're using tape and offset, that's 90 degrees, right? But if it's like that, it's not, and if it's like that, not. So when you're doing it, you swing your tape back and forward, and you know it's a bit there. And because exactly is there, you're only 1 or 2 centimetres away if you're guesstimating it. So the further away you go, that becomes more critical. But you'd be better off using trilateration, so you're better using from the nail to the point, or from the corner to the point, because you've already fixed that. And you'll get the 3 edges of the triangle, and it'll not go anywhere. So you can use that to pick up your key points, like that change in direction, that end up there. And you've measured it as well, so you've actually got 4 points. You get 1, 2, 3, and then you can measure that corner from there. So you can build up lots of measurements, which again proves where it is in space. All right?
Matter that that's not lined up to like the edge of the building
No.
or something like, no, it can be.
No, a surveyor would sat on it and he'd say, I can see that far corner, I can see the inside corner, I can see that tree, I can see that tree, I can see through to put a station on the road, and I can see that bit up there. Ideally, if I was traversing round that way, then yes, I would move it here so I can see down that way. But I just banged it in today, because if we come in January to do the levelling, I need a reasonable baseline for the levelling to show you how that works. So I banged in 2 nails for that at a reasonable distance. So these are purely for the surveyor, what he thinks is the best place to do it, and providing he can see other stations, that's fine. He can then collect that network of these points, control points, and it holds it all together. Then he measures everything else.
So if you're trying to measure from your
Survey nail.
To then say the Nash observatory
Yeah.
there, how, and you're using your tape measure, or you're using a laser, or how do you set it up at a certain height?
Well, if I were using an instrument, the instrument would be set up whatever height, and you measure that height to what's known as the trunnion axis, which is the movement of the telescope. So you'd measure up to that, you'd have it referenced to that station, so you know what the angle round that way is. And then I'd use a glass prism on top of a pole that's 90 degrees, it's got a bubble on it, so I can get it right, and then I can get it exactly that, so that gives me the distance from there to there within a millimetre.
So you just stick a stick over there that's
Well,
got a
well,
special
stick,
debris on
yeah,
top.
yeah, yeah. Or,
Line it up.
yes, a debris, yeah.
Yeah, okay.
Or I can use the non-reflecting laser, and I'll show you one in my bag. It's a distal. You ever heard of distal? Anybody ever heard of distal? Right, let me show you this.
Lost me at trunnion, to be honest.
All right. Right, this, where is he? This is a distal, right? So with this, I probably could go across to there because it's got a sighting bit on there, but I can measure to here, right? And it gives me a distance 6.88 from the face of that to there because it's telling me it's at the face, right?
Yeah.
And you can do volumes, you can do lots of things with it. So it's quite useful. You can do heights if you want to know the heights. So this is quite useful for measuring in. But the trouble is once that dot gets further and further away and you're trying to hold it steady, the distance becomes difficult. So you have got an eyesight, as I say, and it's got a tiny wee cross in it if you want to look through it.
So you'd shoot this over there. You could do
Yeah. And somebody, because again, I'm out of surveying now for years, and I've had this in my kit for years. Somebody the other day just said to me, you know, you can't look through the side and see it. And I went, oh yeah. Because we were trying to hit an A4 bit of paper miles away and it was swinging about like that. I said, I can't see it.
Do you need to then mark on the floor where you're actually taking it from? Because
Well, no, well, if you're doing that and I could do it from the inside of there to the building over there and stuff like that. So,
and then do you have to factor out the size of the device?
no, you can either measure from the front or from the back, and you just need to make sure which one it is. But you can get them quite cheap. I think that was probably about 150 quid, 200 quid, but you can get them cheaper.
And would it go, if you have an overgrown garden that you were measuring,
An overgrown.
yeah, would it go through like
Foliage.
trees and very dense?
No, because the laser will hit the foliage and it'll give you a distance to that. So when you're shooting far away, again, you need to be careful because you think that's a measurement over there, 25 metres, and it isn't. It's 30 metres to the tree. And we have that with the instrument as well. So when we're using the instrument with the laser inbuilt in it, I always focus in and out so I can see if there's any obstacles in the way, because when you're focusing on the corner, you can't see anything else that's in its way. So you need to, again, just be careful.
Presumably you wouldn't want to use a tree as a reference point because
No, not
it's
at all.
circular and you
No.
don't know where exactly
You don't know what the setting is, and that's economy accuracy. You would just take, so if I wanted that tree, I could measure it with the laser from here to there, right? And I could use the little guide to get it and make sure there's no leaves in the way. But then I would measure the diameter of that tree and half it and add it to my distance so it's giving me the centre. All right? And that'd be good enough. But you wouldn't want to go further than that or spend a lot more time in that, because this is the stuff you want to do.
Do you have an issue with different materials like glass?
Yes, it will bounce off glass, because if we'll try it through here, and it'll probably go through the door.
As I say, you get some will bounce and some won't, depending on
Yeah,
the nature of the glass.
the laser scanner will bounce off the glass, and you get it reflected. So you'll get what's ever in there, all you guys, duplicated inside the drawing and outside the drawing, and then you've got to create squares around this to get rid of all that data, and it's really points. It's pain in the butt, to be honest, and mirrors. They're exactly the same. So again, you've got to be careful. And what it used to do, so your man here has just asked, will it go through the glass? So if I hold it here, you can see it on the doorway.
Oh, okay.
Right? So if I ask it for the door, it's giving me 7.791 metres from here
So if you were trying to take a reading off that building over there is a risk you could go through the glass instead
to
of
the other side.
Yeah.
Yeah, and if you look at the, if you've got time to look at scan to go on the portal, which is my scan data, and you pick up the scan data, and there's a way how you use it, you can just look at it and take distances. If you zoom in and look at the scan data, you can see I've actually surveyed the stuff so I was doing the facade of the building and all the detail, but what the laser was doing was scanning stuff inside the building. So I saw pictures and chairs and everything inside, which can be useful if you're going to do stuff in there. Then the scan from outside could be verified against the data you're surveying inside. So, but for me, if I was doing that born of the build, I would survey it from this point, and I would have another station somewhere else, and I would survey it again.
Okay.
So I quite often belt and braces when I'm on a site. Not that I can't remember what I'm doing, but I just like to check it. So I'll take a shot and put it as an MK, a little star with an MK beside it as a marker, on all the trees, corners of buildings, everything from other places, just to prove that I'm surveying it all right and it's all good. And again, if you're commissioning a survey company, you could ask them, what type of checks do you put in? How do you prove your data? You know, as I said at the GPS, the guy was doing all the design with the GPS, setting it all out, but no check on it, because he was never coming back to the origin to see if he got the same position and height. So it was all arbitrary. Well, not arbitrary, it was all related to these satellites, but the trouble was there was no checks on them. So if there's an error in the software, because it doesn't produce an angle of distance or a measurement, it's produced an X, Y, Z relative to the sky, basically. So
I don't know, the algorithms pick me up now, so I keep getting ads for this thing called Mosher, which is like a GPS, connect to your phone, wander around. Obviously it's not going to be in anywhere near as sophisticated as the technology you're using, but having used them, would you say they're useless, waste of time, interesting?
I've got this is an iPhone 14, I think. Yeah. The 15s and onwards have got LiDAR on them. You can buy them with LiDAR. The Pros have got them. And there was a guy at Cambridge Cottage last year. So I was chatting about like this, where if you go on site, you want to take a load of photographs, because when you get back to site, you want to say, blimey, I can't remember that was there. So photographs at any instance is a good idea. Or a video, whatever. But obviously the video you can stop it to have a look at. But certainly with photographs, you can take heights and take a photograph of it. So if you want your wall heights, your fence heights, whatever. But this guy was wondering, says, look at him over there, he's taking photographs of all the site. That's good, that's what you want to do at Cambridge Cottage. And as that was a test site, it was probably all right. He came back and he said, I said, what are you doing, taking photos? He said, no, I was scanning it, LiDAR. And he was just holding his phone out and walking about like this. So then it processed and he showed me it, and it looked very, very good. It was like a point cloud. So a point cloud is lots of that laser shots, millions of them, just together. And the refractive index, or the amount it reflects, gives it a colour code. So where it's glass, it's not very reflective. Where it's brick, it's all right. And where it's white or whatever, you get a better reflection. So it's colour coded, so you get it like a grainy photograph. But he showed me this and I thought, blimey, it's amazing. And then this lady said there was another bit of software that they were getting that could scan things, you mock about with it. And that will certainly save you measuring things and buying things. But again, you need to prove it. So anyway, he showed me this guy. I said, wonder what it's like in the window in the curved area at Cambridge Cottage. So he, on his phone, he went bush, and he came up 1.6 something. So I got this out, I went, it was 1.6. So it was exactly the same. And then I said, let's try some other bits. Then my phone, my batteries died on this, so I couldn't check it. And I didn't think that I could get out the old trusty type to do it. But anyway, we're chatting about other things and it's great. So what he had on his iPhone Pro 15 was amazing. How big that file becomes when you load it into whatever, and whether it can output it in another format to get it into your system, I don't know. But you'd want to do, it's great having it 3D, you know, you get the heights of the trees now, but you want a 2D trying. If you're doing initial design, you want it 2D, because that's where you do your stuff on. You know, you can't be designing a 3D, it'd be too hard. But you could do it, but blimey, do your head in. So yeah, the applications are great, but what you want to do is, it's probably a freebie with his LiDAR connection on his phone, but the trouble is it'll probably cost a fortune for him to get the software to transfer it out to something that he can use. Yeah.
There are some packages I used to work for Apple. So,
oh right, okay.
Yeah. And there is actually a construction company in the Netherlands who've done some really cool things with the iPhone, where they've mounted it on drills and they can get the full plan of the building.
Wow.
And then they can go straight up to the wall and drill a hole
wow.
on the outside of the building.
Exactly where they want it.
Exactly where they want it. Yeah. Without measuring a thing. So like, it's
yeah, but this is what they do for grading as well, because they're using GPS with the level, and then they can tell the grading bucket to grade that for the road.
Yeah.
And it's all automated.
Yeah.
So
sometimes you just have to work out the pain, so you need to like take a picture of something on the floor in order for the for it to work out the structure of the building around you, and then you can hold it up to the wall. And look at it.
So, I mean, this is what you say. I mean, I've stopped surveying about 4 or 5 years ago, and as much as it's ingrained in me, I've still got to think, and I can't keep up as much as I'd like to keep up with the technology, because it's just running ahead so fast. But the thing is, it's like everything. It's great, but you need to know what it's based on, what it's control, what's its baseline, where is it coming from. So yeah, that Apple phone is probably taking distances, recording like this all the time, so it knows when it's got to the building, it knows the building's 350 thickness walls, and it'll drill straight through. That's fine. But then as it does the next bit, it needs to recalculate all that information. So that's fine in isolation, but the way that you guys are doing it, you need something that's giving you an overall plan or an overall scheme. And there's lots of things out. AI can do lots, but again, it all goes back to how does it all work? And it all works by purely measurement in one form or another. So as long as you can verify that and check that by physical means or digital means that you can rely on, then you've got nothing to worry about. But yeah, we're going to get to the stage that you're going to give it a site and say to AI, right, design me a garden. And it's not what it does, it's how you feed that information. And if you feed it the right information and the right criteria and your requirements, will that do you guys out of job? Well, certainly surveying as far as drones, automated drones, to provide LiDAR scans and all that, and people can then take measurements from it, but they need to relate it to some control, something to pull it together, because otherwise it's meaningless. It's a pretty picture. And it might be fine for lots of things, but if you're getting down to some of our stuff is millimetres, like when I was on the Thames barrier, we were doing the shift and latch, which is the engineering part that brought up the barriers. And I would set up my instrument over there, and then the guy would push me out the way and he'd check that, set it up correctly, and I had my bubbles all right. And when I physically measured from there to there, I said, right, we need to check that. And I'm thinking, cool, blimey. And it was very off-putting at first, because I thought, does he think I don't know what I'm doing? But it wasn't. They had to ensure that the quality of the work was as best they could get it. So you get confidence after that, he's checking it all the time, but you know it's okay. So it's down to everything. It's down to what do you need to achieve, how you're going to get there, what methods or systems you're going to use to provide you with that, and then can you come up with something that's good. I mean, they're saying now with music, you know, they're saying that AI can create all the pop music, all the music today, because they can give it all the stuff it needs. It's got the algorithms and the way it goes. So it takes out the human element. But I've got a system that I started using, and my brother came round. He used to be a drum roadie with Jethro Tull, so he was into the music system. And this box had a drum machine on it, and one of the buttons is human. And this is probably hardware and software that was written 20, 30 years ago, and it had a human button. So we played about with it, and he said the human button was amazing because it gave it a human feel that either was before the beat or after the beat, or just made it up as it went along. And that was quite an interesting bit. So if AI is going to be any good, it's going to have to put in a human element so that it makes it feel real. Because otherwise it becomes robotic and alien, and it doesn't feel.
I think it's also the use case, so like BAM construction, using the development that they take in the scan, so that the surveyor could talk the people going into the job through it in a much more intuitive way.
Right.
And they could be like, you need to be careful of this and be careful of that, and because they were doing like loads of apartment blocks and they couldn't get access all the time, so the ability to actually say something in 3D and turn it around and be like,
brilliant,
be careful, the pipes don't go over the window, this is exactly how close they are.
And there they are, because I can show you them.
So it was much more about empowering the person to do a better job than taking away the person's job.
Sure.
Yeah, that's right. And stopping the errors. I mean, that was the idea of BIM, was it, as you said. The BIM was you can do a survey, do your design, put your design on top of the survey, and then you can find out what your quantities, how many doors you need, areas of carpet, areas of cladding, the whole lot of it. And then from demolition and recycling, you know exactly what you've got, and you can maintain it. You know that's how much rental income you're going to get on it, and the whole thing just pieces together. But the initial surveys, putting surveys into a full BIM model, it took a lot of work, an awful lot of work. and you can't let it run away with it, because again the things that doesn't look right. And I've done lots of surveys of buildings where the client comes back and says that doesn't seem right, the walls are bowed or it's not square. I said, well, that's what it's like. And they can't believe that it was designed by an architect to be square, but once humans get involved and set it out, you actually got it a little bit bent. So whereas sometimes you might get a survey that looks wrong, it might actually be like that. But hopefully it's been useful today. I don't know if anybody else has any questions, anything else. I mean, somebody was asking about the girls, you know, were they going to go back in and was going to show them anything else. In previous years, we went through some of your design drawings just to interrogate it a bit more, to find out what the line work was, what the abbreviations were, or what it all was. But I mean, if you want to do that, I'm quite happy to do that. If you're happy with it, what you've got, and you can interrogate it later, it's fine.
Did you say there's another session in January looking at levels?
This session in January looking at levels, yeah. And that'll be quite interesting. So again, we're looking at measurement in 2D, but when you do the levels, you can find out how you can further check surveys or take something on yourself, because I show you the ability how to read a level, how to take distances with a level, and just how it all works. So again, when you're seeing a builder on site, you can look at it and you've got a better idea of whether things are going to be right. Because again, you don't want to leave that hole half a metre lower or higher than it should be, you know, because you need to drop a tape down it, or you've got a level, set it up, back sight off your floor level, into the pit, reduce your level and say, yeah, it's half a metre, and then you can show me next day and say that needs to go down a bit more. So you don't leave it by not understanding it. Also, you get to the end of it, you start bringing in your materials, you've got rid of the digger because you think you don't need it anymore, and yet you find out that the hole's not been dug deep enough. So you need to be on the ball with it all, because if you rely on the contractor to do it, he might not be as keen as what you are, and might not understand the implications of getting things wrong. Yeah. Okay, so that's now what, 2:30. Unless you've got anything else, that's about it, wrapped up from my end. Yeah? Yeah? It's all right. But again, if there's anything else you think about, drop me an email or a text or whatever. All right.
We've got a project due tomorrow, so I think everyone will be very happy to have the extra time.
We're all on a deadline, so I think we're all a bit.
So that's not a steel one, is it?
No,
that's
it's...
just I've got one. I don't think it's a Stanley, but I think it's just similar material.
Yeah.
So you're saying they can stretch a bit.
Yeah, this you could stretch over, pulling it over months, if not years, but you're only talking about half a centimetre or something. But again, temperature's going to alter it, you know, if it's too hot or too cold.
True, the material can.
So again, in what accuracy you're getting down to, but over this, I think it'd be fine.
Yeah.
But you can get a lot of cheap tapes coming in that are really cheap. If you go with something Stanley or something like that, and you can pay a wee bit extra for if something that's fiberglass, it's a bit thicker, so therefore it's a bit more robust, or it's got steel in it, it'll be fine. All right, cheers. But yeah, it's all horses for courses, really.
Yeah, and practically, I mean, you expertly grip that wall, but if there's a second person,
it makes it easier, but you can't.
Easier.
Yes, it does, but you can get bamboo canes, so I could. And blue tack. I mean, blue tack would stop it dropping, and I've just wedged it behind the lightning conductor, so at least it didn't fall down. All right, cheers. But you could use blue tack or something, or a brick tie at the end of it. All right, cheers. Anything, but yeah, you can't afford a second person a lot of the time.
No. But if you've got a friend or something.
Yeah, just for for the long
or
measurements.
Even the client, if they aim for it.
Well, you can. Yeah, that's right. But you can do all the local stuff quite easily with 5 metre tape or something.
Yeah.
And the long stuff, you can do this offset that, or triangulate, trilaterate it, because you can punch in a bamboo stick or a bit of a survey arrow, which is just a very thin bit of steel with a hoop in the top, and you can poke that in soft ground and maybe between cracks. All right, cheers.
Yeah.
So there is things that you can get to help, but yeah, ideally if you want to get somebody to help you, it would be much better.
Yeah. No,
All right. everybody. I was talking to the students the other day there about Stanley right angle square. It's a handy piece of kit because what it does enable you to do is take right angles to offsets, but also use it if you're going to be going over walls or you've got anything bumpy. So I'm assuming that I've used the baseline of the building, produced this out, and I want to fix this. So I can use the straight edge with the right angle to give me the offsets to points of detail. And it just, but you can swing your tape back and forth just as easy, but certainly if you're going a long way, at least you're getting a good right angle to do it. But the big advantage is if you wanted to come over a wall or whatever, and you've got this scenario, your tape is going to be wrong. But if you use the right angle square on your detail that you want or another survey point, it doesn't matter if it goes back and forward because you're getting the correct distance from the point to the point, and you're not using any slope correction. It's trying to get its horizontal as proper, as good as you can. All right, so this is a handy piece of kit. It's about 40 quid, 30, 40 quid thereabouts, and it'll just assist you on getting right angles, and it's helpful, as I say, for measuring over walls, obstacles. You've got a chainage point or a baseline point, and you've got another point here, it's the other side of the wall. You can use this to get you that horizontal distance. All right, cheers for your time.